Hi everyone, we're going to evaluate the derivative at a given point, which is this one right here. We're mainly going to be looking at the x, plugging that in, and we're going to use the chain rule. So first thing we're going to do is find the derivative, and since there's just a simple numerator, I'm going to rewrite this as x cubed, 3 times x cubed minus 4 to the negative 1, and then just use the chain rule. So basically we're going to take the derivative of f, and we do the outer function first. That's going to be negative 1 times 3 is negative 3, x cubed minus 4, and negative 1 minus 1 is negative 2. And then you take the derivative of your inner function, which is going to be 3x squared. Alright? So then I'm going to take care of multiply these two together. That's going to give you negative 9x squared. And I'm going to move this quantity in the denominator, so it's going to be x cubed minus 4 squared. Now we're just plugging in negative 1, and when you do that you're going to get negative 9 on the numerator. So basically we're evaluating negative 1, so you're just plugging in negative 1. And then squaring it. So you're going to get negative 9 over 25. Okay, the next one's very similar. Our numerator is pretty basic, so I'm going to rewrite this as x squared minus 3x to the negative 2 times 1. It's just that. And the x we're going to plug in is 4. So we take the derivative of f, and using the chain rule, we're at negative 2, x squared minus 3x. Then that's going to be to the negative 3 because you're subtracting 1. Then take the derivative of your inner function, which is going to be 2x minus 3. And simplifying this, we're going to get negative 2 times this piece over this part. I'm going to bring this guy in the denominator and clear that negative exponent. And then just evaluate 4. The derivative at 4. So we get negative 2 times 2 times 4 minus 3 over 4 squared minus 3 times 4 cubed. And that's going to give you negative 5 over 32. Right, the next one, oh, that's the all for this one. The next set I'm going to do is the same thing, but our numerator is a little more complicated, so we're going to be using the quotient property. Thank you. Have a nice day. Bye-bye.